Hi everyone. Have you heard of an integration between WebAssembly and Azure Kubernetes Service? October 13, 2021, CNCF announced that it supported AKS in distributing workloads in Kubernetes using the Krustlet project and WebAssembly System Interface. Here, we need to understand two concepts: WebAssembly and Krustlet. First of all, what is WebAssembly? Let's ask Nigel Poulton, one of the experts and Docker captain, for the best explanation on this topic. Hi Nigel, how are you doing?
Yeah, I'm good, Cheedo. How are you?
Yeah, I'm great, thank you. What's the weather like in England?
Oh, well, it's the British summer, right? So it's rubbish. It's like 18 degrees and raining, so like 65 Fahrenheit, I think. It's awful.
Oh, it's cool. It is 34 in here.
Oh, I'm jealous. I'd love that.
Okay, let's go back again. We want to learn about WebAssembly. Please explain to us what WebAssembly is.
Yeah, okay. So I think the first thing I usually say to people is that WebAssembly and WASM are the same thing. So if you hear somebody refer to WASM, then they're referring to WebAssembly. But I like to think of it as like a new virtual machine that's like smaller, faster, more portable, and more secure than a traditional container.
Could you please give a bit information like advantages?
Yeah, so I think on the smaller side of things, it's not uncommon for a WebAssembly app to be like quite a lot smaller than a container. So sometimes you can have them be, kilobytes or in the low megabytes because you're not compiling in some operating system components like you do with a container. On the faster front, again, if you configure a WebAssembly application right, then it can start in microseconds, sub-milliseconds sometimes. So really good for event-driven serverless environments. I think I said more secure as well. So the WebAssembly sandbox is a deny by default sandbox, and it's been battle tested over years in like all of the major web browsers as well. Oh, you know what? I mentioned portability as well. So the way that WebAssembly works is you compile your application, and instead of compiling it for like Linux on ARM and Linux on x86 or whatever and having multiple binaries, you just compile it as a WebAssembly binary, and then that will run anywhere that you have a WebAssembly runtime. So yeah, smaller, faster, more lightweight, secure, and portable.
I really appreciate your clarification on this matter. Thank you so much. Everyone, if you have any question about WASM, please just DM to Nigel, not me.
Yeah, that's cool.
Cheers, mate.
Yeah, cheers.
We learned this concept from Nigel. Now, let's continue to talk about Kubelet and Krustlet. The kubelet is the primary node agent that runs on each node. It makes sure that containers are running in a pod. What about Krustlet? Krustlet is a Kubernetes kubelet that runs WASM on a WebAssembly runtime rather than containers. It is written in Rust. Its name comes from the combination of kubelet and Rust. For example, when Krustlet is a pod assigned by the scheduler based on specified tolerances in Kubernetes, it performs similarly to a kubelet by listening to the event stream. It acts as a kubelet. In other words, it listens on the event stream for new pods that the scheduler assigns to it, of course based on specific Kubernetes tolerations. This is an important part. When working with AKS, we set up our pods on node pools. These node pools' default workload runtime is OCI container. It allows the Docker images you created to run. But what happens when the runtime is different? When compiling with WASM, as previously noted, we require a separate workload runtime. Krustlet allows you to create WASI node pools and schedule WASI workloads to run on Azure Kubernetes Service. Here, two things change with the time. AKS originally used Krustlet to execute WASM modules on Kubernetes, but they now use container schemes. If you continue to use Krustlet-based WASI node pools, you can migrate them to a new WASI node pool that uses container schemes. Let's add some notes here. This is an AKS preview feature. Therefore, it is not recommended for use in production environment because you may not be able to get help. However, you can use it in a development and test environment if you want. There are also a few limitations between AKS and WASM. These are: the WASM time runtime only uses containerized schemes for applications. Containers like WASM time runtime apps can be executed in WASM or WASI node pools. Containers and WASM modules can be run on the same node, but not in the same pod. WASM or WASI node pools are incompatible with the system node pool. The operating system for WASM or WASI node pools must be Linux. And the last one is that you cannot create WASM or WASI node pools through the Azure portal. You must do it from the command line. Here we have an exercise. Before you start, make sure you have the latest version for Azure CLI installed on your local. If you have Azure CLI, you can use AZ upgrade command for it. The other thing is that you need to log in Azure on your local environment. There's a command we need to run first to install AKS-preview extensions in our AKS cluster. For this exercise, I assume that you have already AKS cluster. I would like to show you the cluster. If you don't have it, please create. Now let's run the command using Bash or PowerShell. AZ extension add --name AKS-preview. Here we need to run the command to update the latest versions of the extensions. AZ extension update --name AKS-preview. If you have already it, you can update. Now let's run the register verify and provider commands for the WASM node pool preview feature. For it, AZ feature register --namespace Microsoft.container service --name WASM node pool preview. This command may take a few minutes to register here. You can verify it after a few minutes. AZ feature show --namespace Microsoft point container service --name WASM node pool preview. When the registration process is completed, let's run the provider command. AZ provider register --namespace Microsoft point container service. So far, we have been able to register the WASM node pool preview feature. Now we will add the WASM or WASI node pool to our AKS cluster. We will do this from the command line. We apply the AZ AKS node pool add command to add the WASM or WASI node pool to AKS cluster. For adding node pool, we will use AZ AKS node pool add command with the resource group, cluster name, node pool name, node count, and workload runtime. For now, it is fine, one node. You can also increase the number of nodes if you want. Now the node pool has been added. As I said before, the default value for the workload runtime parameter is OCI container. This command can be used without using this option if you wish to add a node pool to run your containers on. If you want to use this parameter, the value must be OCI container. After running the command, let's verify the value of workload runtime for the node pool. As the AKS node pool show rg-çiğdem, cluster name, WASI pool demo, and query. When we look at the result, we see WASM WASI. Now let's look at our nodes in the cluster to check. As you can see, we have 1, 2, and 3 nodes now, and one of them is WASI pool demo node. Let's look into this node in more detail. I will use node name with kubectl describe node command. Here are the details about the node. Now, let's test an application using WASM time. For it, I will use the YAML from the Microsoft documentation. I will share it with you. As you can see from the YAML, we need to specify the runtime class name so that Kubernetes understands this application as a WASM module. You can configure the container runtime using runtime. By the way, this capability was added to Kubernetes in version 1.12. Those who use previous versions may have trouble using this feature. Please check the Kubernetes version. Now I will apply the YAML to our AKS cluster. I will use kubectl create-f test YAML command. After applying the YAML, we can check the application. Before we check the application, we will need the external IP for the application. You can also check it from the Azure portal or using kubectl get service command. Here we have this external IP. I will use this one. As you can see, we got the response. You can also use Nginx ingress instead of using external IP. When everything is done, we need to delete all resources. First of all, we can delete this application. For it, we can use kubectl delete -f test YAML command. If you want to delete this WASI node pool, you can do it both from the command line and the portal. Remember, we need to use command line for creating the WASI node pool. On the other hand, for the deletion, we can use both. For command line, as the AKS node pool, delete --name, WASI pool demo, and resource group and cluster name. Before delete it from the command line, I want to show you it from the portal. When you open the Azure portal, you can check settings, node pools, and here we have this WASI pool demo. You can click If you want to delete it, you can click delete, or you can also scale node pool to increase or decrease the node number. As you can see, you can also use manual and auto scale methods. You can also stop node pool, upgrade Kubernetes, or update image if you wish. As a result, WASM is designed as a portable compilation target for programming languages, enabling deployment on the web for client and server applications. You can also use it with Azure Kubernetes Service. Thank you for listening. Have a great WASM and AKS day, everyone.